But so today I'm going to cover reading and writing files. So let's start with another main. And let's create our main function. And in the great tradition, we'll start with hello world just to make sure everything's okay. All right, fantastic. So we have files on computers, and we occasionally need to read and write those files. Now, at the last stream, we came across the response writer. Go look that up real quick. Net HTTP. I guess it's in this one, right? So response writer. Response writer lets you write a slice of bytes to the requesting web browser. This is kind of based on the write interface for writing to any file. So we've already seen this kind of paradigm, and we're just going to take another look at it with the relationship with the eye towards reading and with the goal of reading and writing files. So what's a file? A file is a sequence of bytes on disk, basically. So let's use our program source code as our source data. So let's do, how do we get to a file? So the first thing we need to do is open the file. Open is in the OS package, which is one of Go's standard packages. So we open the file. We want to give it a file name. Now, since we're going to be running this program from the same directory as our source code, we're just going to open our source code. Okay. What does open return? Open returns a file or possibly an error. So we'll call this in file error. What kind of errors could it return? Well, maybe the file doesn't exist. That could be one error. So if error not equals null, we're going to just go ahead and print the error. Okay, and I'm introducing a standard way that I handle returned errors, and that is to give a useful message and then print the error that we see. Okay, now that we have our file, we can take a look at our file and see that it is a type of OS file. And if we go to, we have to open up the OS package. This is long, isn't it? Types file. File represents an open file descriptor. A file descriptor in kind of Unix talk represents an interface into the operating system that lets us read and write data. Now, the file implements the reader interface. So if we look into the I/O package, we see the reader interface. The reader interface has one method. It's to read some bytes from something. Now in this case, our something happens to be a file returned from the file system, but it could be, there could be anything that can return to us some bytes could be a reader. We could make up a reader, like we could have, in fact there is one that reads random data from the operating system's random device, which generates high quality random numbers. So we'll start by reading some data, and we'll store the data in a buffer, and we'll just create a buffer of size 10. And we'll go ahead and in file .read buffer. Okay. Now, what does read return? The read interface from I/O returns the number of bytes read for the file and possibly an error. So bytes read, error is equal to. Okay, so now again we use the same pattern here. Let's tighten this up so it indicates it goes together. If error not equals nil, we go ahead and print the error. Put in our new lines at the end of here. And actually one of the things we want to do is, if we can't open the file, there's no point in continuing. So we're going to go ahead and exit at that point. And as traditionally when you have, not traditionally, it's kind of really expected. If you're exiting because of some sort of error condition, you exit with a non-zero value. Same thing down here. If we can't read any data, there's no point in continuing, so we're going to go ahead and exit. The non-zero value indicating that there was some kind of error. That allows someone who's using this program to check the returned value from the program and see whether or not it was zero. And if it's zero, everything went fine. If it's a 1 or more, something went wrong. So let's go ahead and print the number of bytes read. Now let's go take a look at the type of bytes read. Bytes read is an integer. Now what's interesting is an integer can only go up to 2 gigabytes in size. Certainly we have files that are larger than that. You probably have movies on your hard disk that are larger than 2 gigabytes. So even though the number of bytes read is in the order of 2 gigabytes at a time, the actual underlying implementation looks at bytes and positions in bytes and so forth using 64-bit integers, not 32-bit integers, because bytes files can be much longer than 2 gigs. So we're going to indicate the number of bytes we read, and then we're going to print the bytes. Now, we read above a byte slice, and we're going to print a string. So we're going to convert the byte slice to a string and go as a nice easy conversion. Just as we could turn a string to a slice of bytes by using the that kind of paradigm, that kind of type. It's not really a type assertion, it's kind of just a type promotion. Anyway, let's go ahead and run this. I read 10 bytes. Okay, great, that's what the size of our buffer, right? Read 10 bytes. It's possible that when we read data from a file that it could read less than 10 bytes, but it hasn't gotten to the end of the file. So when could that happen? Like, let's say you're reading data off a network connection. So your file represents a network connection. and you read the first 1K of data from that network connection, and the next 1K of data is waiting for the other side to send data. So if you try to read 2K, you would get 1K back, and then you'd have to go back for the next 10K, or sorry, next 1K. Oops. So, okay. So we've got the ability to read data. So it would be really awkward if we had to figure out how big the file was and read it all into one buffer. Also, if we knew we were going to read the contents of an entire file, we might write a function to do that, right? Well, Go already has a set of utility functions that we can use. So in the IO util package, we have read all, which the most common ones to use are read all, which reads all the stuff inside a file. And we have read file, which just goes ahead and reads in the contents of a file without us having to open the file first. So this, to read all the data, we would have kind of said IOUtil read all, and read all takes a reader, and our reader is our file. It's what implements the reader interface. And in this case, if we go run this, oops. Oh, let's check that out. I didn't expect that. Let's go to read all. Reads from R until EOF. Okay. So bytes read. Oh. That's right, it returns the byte slice and an error. So this would be buffer. Oops. So let's do this. And we don't get that back. So we just get, if we look at read all, we get back the bytes that we read and possibly an error. Okay, so if we run this, sorry, excuse me, we get our program code. Okay. So read is kind of the base call. The IOUtil package takes some of those calls and gives us higher level constructs, so we don't have to keep going back and forth. Now what happens if we do go back and forth and we run into the end of the file? So in that case, we get return an error. So let's take a look at doing what read all does, but let's look at doing it manually. Actually, but first let's take a look at read file. So we could go ioutil.read file. And that returns a buffer an error. We'll just go ahead and exit. So we go run this. We see that it does the same thing as the previous program did, but just in a lot less code. Okay, so now let's go look and see what happens when we want to read a chunk at a time. So let's do this. Let's go back to our original. Okay, so in this case, what we're going to do is we're going to have a fixed size buffer. The buffer is going to be 10. Okay, so we'll use 10 bytes as a buffer. and we are going to say actually we're going to do this. We're going to say so we're going to ignore the bytes read, error, and we're going to say while error sorry, for error equals nil or error, so while error for error equals nil. Okay, so this is going to repeat until error is not nil, and then down here we'll do it again, right? We'll read more data. Oh, no new variables on the left side. Okay. So this will read 10 bytes to kind of prime the error value. Then we'll loop through until error is not nil, and we will read data. And what we'll do here is we will use we're just going to head and write the contents of buffer. And here, one last time, we'll write the contents of buffer. Oh. Oh, that's why. So we go ahead and run it again. Interesting. So let's take a look. So this would be going on until error returned a non-nil value, which is what we expect. We expect this to return the value io.eof. Okay, so if error not equals we'll print this. Oh, because we're getting garbage at the end of the buffer. So we do need to track the bytes written. So we'll track the bytes read, and we will print up to bytes read. And we will print up to bytes read. There we go. Okay, so let me explain what's going on. So we're opening a file, we're creating a buffer, we're reading to initialize our variables, and then we're going through a for loop. As long as the error is nil, meaning we haven't reached the end of the file or had some other error like the file becoming unavailable, we go ahead and write out the contents of the buffer, but we only want to read the bytes that we've read. So we have a buffer of 10, maybe we've only read 8 bytes. We don't want to print the last 2 in that buffer because they could be garbage. So we only want to print from 0. This is a shorthand way of saying from 0 to bytes read. Okay. Then we have to read again. And as long as the end of file or some other error isn't returned, bytes read will always contain the number of bytes. Now, the last time you read from something, It's supposed to return an end of file and some data, or uh, no data and an end of file. So either this contains some data that we need to print at the end, or it doesn't contain any data. Either way, it's fine. We just print the contents. If bytes read is 0 on the last read, that's fine. This will just print nothing. Okay. What's the other thing I wanted to cover today, just really briefly? Oh yes, buff.io. So sometimes what we want to do is read a line at a time. So we go ahead and use the buff.io package. So reading a line means we read until some sort of end of line character, right? So we're going to use the new reader function and pass in our file. And this creates a buff.io reader. So we'll call this buff reader. Okay, so buff reader does have a read line function. However, we don't normally use that function. Instead, we use read when we use ReadBytes, and we tell it where to stop. So we're going to go ahead and stop on that. ReadBytes returns the slice of bytes and probably an error. So data read error equals. Now, if we go look at the documentation for ReadBytes, so ReadBytes. ReadBytes reads until the first occurrence of delimit input, okay. If ReadBytes encounters an error or returns the data read before the error itself, great. So we might get some data and possibly an error. If there's an error, ReadBytes returns error not equals nil if and only if the return data does not end at a delimiter. Meaning we'll get an error if the data does not end in a delimiter, such as an end of file, and in fact, the error is commonly end of file. So let's go ahead and read our file a line at a time. So for error equals nil, so while the error is nil, we are going to go ahead and print f, and we're going to, again, we're always reading slices of bytes, so we've got to turn those back into strings. And we're going to keep doing that, and again, we have to go back and read more data. And so possibly we have to here we go. Okay, so here's our program reading a line at a time. So what it's going to do is it's going to read bytes until it gets to a new line, and it'll return. And then it's going to read bytes until it gets to a new line and return. It'll stop when it gets an error, and in this case the error was an end of file. Now again, there could be other reasons why you have an error, such as, for example, if you're reading from a network, the network connection could get dropped. If you're reading from a bad disk, the disk could have an error or whatever. But generally speaking, most often it's end of file that you'll encounter. Okay, so that was kind of a little bit of a whirlwind tour, and I just want to quickly go over one of the, to open a file for reading, you use the open system call, which is in the OS package. To read data in and out of the file, it uses the reader interface. So let's take a quick look at the reader interface. So let's take a look at reader. Yep. Oh, there we are. We're on reader. Huh, interesting. Oh, there it is at the bottom. Okay, we're on reader. So it has one method, and that is to read a byte. There are variations of reader. So the most common variation of reader that you'll run into is ReadCloser. ReadCloser is both a reader and a closer, and a closer just gives us a close method on something. So here the file gets closed because our program ends, right? So normally, and if we look at infile, we'll see that it does have a close method. So it's a ReadCloser. It's a reader. That's true. It satisfies reader. ReadCloser is something that satisfies both reader and closer. And since it has a close method, it satisfies closer. So it's a ReadCloser. Closes the file. So what would happen if we kept opening and reading from files over and over again without actually closing the files each time? Excuse me. The short answer is eventually we get an error saying we'd used up all our open file descriptors. I should say actually we should get an error that says that. If the file gets garbage collected and gets closed that way, we might not actually see it for a while, but eventually we'll open up enough files faster than our stuff's garbage collected that we will run out of, the OS will tell us we can't open any more files, basically. So we handle that situation by using a call called defer, or a keyword defer, and then the function we want deferred until the end of this function. So we're going to defer in file. Okay, so what's going to happen? We're going to do our stuff, and what we've told this is that when main exits, run this. So we've basically set this call up to run at the end. So we'll do our stuff. We don't worry about closing the file down here. We don't have to worry about, you know, let's say we had a bunch of tests like, you know, if error not equals nil. Sorry, that will never happen, right? So let's say we had something in here like if error not equals nil. We wanted to exit, right? Well, if we didn't use defer and we just called infile.close at the end of the, if we just did something, instead of using defer, we just did infile.close at the end, what would happen here is we'd return from main without first closing our file. So that's why the normal pattern you'll see is to defer close. That way it happens regardless of whether we return somewhere else in the program or not. If we go ahead and run this, what did happen is the file, I can prove to you the file is closed by doing something like this. Func, this is another common pattern you'll see. You'll see this wrapped in a function which is immediately called, because when you use defer, you're deferring this call and you've got to give it the full call to the end of the enclosing function. So we're just going to go format println done. Go ahead and run this. There. We see it prints I'm done at the end when it executes this deferred function. Okay, so that's basically it for reading data. We've got opening, we've got reading, we covered the convenience functions in IOUtil, and that's, we looked at read all, but it has read file. We actually did look at read file as well. We took a look at the buff.io package and the ReadBytes function, especially to read a line of the file at a time. And we took a look at the OS package where files defined, and we can see that file has the read method that makes it a reader and the close method that makes it a closer, so it is a ReadCloser. Okay, that's it for reading data. That should get you started with that. I think the next time through we'll do writing data. Yeah, those are the two kind of key things that we need to cover to be able to do more useful stuff. So, yeah. Okay, well that's it for today, and next time we will cover writing data. All right, take care.